Guys, now please confirm to me. All of you get my voice on screen. Those who are attending in online. Guys, now please confirm to me. All of you get my voice on screen. Those who are attending in online. Am I audible, guys? Now please check it. Everybody. Yeah, Anil Reddy, are you there? Yeah, good morning. Good morning, guys. Good morning to all. Yeah, Anil Reddy, please confirm to me. Are you there? Anil Reddy, are you there? Right. Right. Good morning, guys. And can you check it? What we completed in the last session? I think so. We are discussing about Java features topic, right? Tell me, what is the purpose of this Java features? What is the why we are understanding this Java features topic? Any idea? Right. Answer is very clear. To describe the nature of the Java programming language, to describe the nature of Java programming language, we have Java features topic. That's the main intention. Okay. How many features are available? 12 features are available. Understand it now. Just in our simple statements, if you want to understand, it's a trailer part for Java programming language. It's not like a main core, just it is a trailer part. If you want to know what is Java in 5 minutes of time, Java features is the best option. Easily we can understand it. So nearly 12 features are available. Simple, object-oriented, platform-independent, architectural neutral, portable, robust, dynamic, secure, multi-threaded, distributed, interpretive, high performance. Clearly. Now, I think almost all up to multi-threaded we completed there in the last session. Just 1 minute. I want to review all the points here, but you have to give answers for my questions. Tell me how Java is a simple programming language. Three reasons. Simple answers I require. I don't require descriptive answers. Right. Tell me what are the three reasons? No. Less execution time, less memory. Next one is no confusion oriented features. Next one is what? Simple syntaxes. Remember, we have to remember. We have to give the active answers clearly. Right. Next one is how can you say that Java is an object oriented programming language? Able to represent data in the form of what? Objects by following what? Object oriented features. How many object oriented features are available? 7 number of object oriented features: class, object, encapsulation, abstraction, inheritance, polymorphism, message passing. Right. How Java is platform independent programming language? Compilation is on one operating system, execution is on another operating system. Nice. How Java is an architectural neutral programming language? Compilation is on one hardware architecture, execution is on what there? Another hardware architecture. How portable? Able to run its applications under all the operating systems, under all the hardware architecture. Just remember, platform independent and architecture neutral. Both if you mix there, it is what they're portable. Clearly, if you want to talk about it, without having changes in our program, we can change the operating system, we can change the hardware system for our Java programs execution. I'm going to say that Java is a robust programming language. Two reasons: good memory management system, good exception handling mechanisms. How good memory management system is available in Java? Heap memory management system. It's a dynamic memory management system. It allocates and deallocates memory for the objects at runtime as per the application requirement. But how memory manage, how exception handling mechanisms are good in Java? Why? Because Java has provided very good predefined library to represent and handle almost all the exceptions which are coming frequently in Java applications. Leave it. How Java is a dynamic programming language? It allows memory allocation at what time here? Runtime. Dynamic memory allocation. Java is following what? Dynamic memory allocation. How Java is a secure programming language? three levels of securities it is providing. What are the three levels of securities? No, implicit security, web security, explicit security, network security. What is how implicit security is good in Java? Because of security manager inside the JVM. How web security is good in Java? Because of a separate middleware service provided by Java in the form of JAS. What is it? JAS actually Java authentication and authorization service. How network security is good in Java? Java has provided predefined implementations for each and every encryption and decryption algorithms. Means that network security algorithms implementations are available. Because of that reason, network security is very good. Right, sir. Now, how Java is multi-threaded programming language? Java is following multi-threaded model. What is that multi-threaded model? Which allows more than one thread at a time, which follows parallel execution. It reduces the application execution time. It increases the application performance. Because of that reason, Java is attracted for multi-threaded model. Java is following that. That's why Java is what there a multi-threaded programming language. I think up to this part here we completed in the last session. Got it? Please again and again I'm telling to you, when I ask a question to you, immediately response I require from each and every person. How people are sitting today in my class now, only I can count the members on fingers. Max, those who are giving active response. Max 6 or 7 members are giving active response, or maybe max 10 members. But all remaining members are some people are blindly, ideally sitting inside the class and looking my face only. Even no movement on your lips. And some other people are, I observed clearly, some other people are they are giving movement on lips now, but sound is not coming. I understood that clearly. That sync is not available, right? When I heard the statement there, then what you are giving that lip movement is totally different. Right. See, so no need to go for such kind of things now. Only the point is what? It's a reality. In your up to your BTech or MCA, just you studied everything for the sake of exams. But now you are studying everything for the sake of your life. Everything is going on reality here. It is a reality show. No scripted, no actions, no cut and paste, right? It's very clear. In front of interviewer, you have to respond for the interviewer question. If you respond properly for that interviewer's questions, then you are going to be selected. It's straight. It's very straight. No twist and no other things. No. You have to perform well. Then only you are able to get jobs. If you are not performing well, we will not get jobs. Clear information. Okay. As per that, what I'm telling you again and again, I'm requesting to you at your home, check one time the total content. You'll understand it. Max level. I try to inject the content with you. All right, complete information I'm giving there. At the same time, short forms also I'm giving to you to remember the concepts. At least before going to start the class, when you came here. Anyway, I'm coming here by a bit 10 minutes or 15 minutes delay there. Meanwhile, try to check the content. That you can think it is what their grace time. Better, right? Right. Don't give this type of opportunity to talk again and again the same kind of nonsense inside the class. No, I'm not here to alert you, right? I'm here to teach the Java. Time is very important for you and for me. Okay, that's why then take your own responsibility. And so my point, every day I'm giving this kind of messages. No, is getting boring. Okay, even for me it is getting boring. So try to take your own responsibility. If I ask a question, the entire class has to give response to me. No? Right. Now let's move to the point here. Next one is distributed programming language. Right. So what is this distributed programming language? How Java is a distributed programming language? I'm giving clarity to all of you now. Try to understand it. No. By using Java, we are able to prepare two types of applications. By using Java, we are able to prepare two types of applications. What are the two types of applications here we are able to prepare? No, there are two types of applications. What are the two types of applications here? The first one is standalone applications. Some of you may be aware about it. The second one is what there? Distributed applications. First one is what their standalone application, and the second one is what their distributed application. So what is standalone application? You already aware about it. What is the meaning of this standalone application? Definition is very clear. If it design and execute any application without client server architecture or without distributing application logic over multiple machines, without distributing application logic over multiple machines, then that application is called standalone application. Tell me guys, what is a standalone application? Application without client server architecture. Application without client server architecture or without distributing logic over multiple machines. By distributing the total logic in a single machine, by distributing that entire application logic in a single machine, that application is what their standalone application. Observe carefully. To prepare standalone applications, Java has provided a set of libraries in the form of the packages like to prepare standalone applications. Java has provided a set of libraries in the form of packages like java.lang, java.util, java.io, and so on and so on and so on. That's it. Now these are the simple packages are provided. Just simply what I'm telling there, J2SE. To prepare the standalone applications, we are having the library like what there, J2SE, a separate module is available. That's a fundamental. It's mandatory for everybody, right? Right. But exactly, what is the meaning of these distributed applications? Distributed application, as you see already, the definition for standalone application, it's very simple to talk about this distributed application. What exactly the meaning of distributed application? That's my question now. Right, sir. If we design and execute any application on the basis of client server architecture or by distributing application logic over multiple machines, then that application is called distributed application. That application is called what there? Distributed application. To prepare distributed applications, Java has provided a separate module. Java has provided a separate module in the form of J2EE, in the form of what there? J2EE. Because of this reason, because of the J2EE module, because of this J2EE which is provided by Java programming language, Java is what there? A distributed programming language. Java is not only for standalone applications, it is also be for what there? Distributed applications. One more point I'm telling to you, observe carefully. Standalone applications are only 5% in outside market, but distributed applications are 95%. That means Java is not having main focus on standalone applications. Java is having main focus on what their enterprise applications, distributed applications. Because of that reason only, that J2E was provided in a vast syllabus. The J2E was provided with very good R&D work because of providing applications for what their distributed applications. That means enterprise applications. So due to that reason, we can conclude that Java is what their a distributed programming language. Java is a distributed programming language. Why? Because Java has provided J2EE module to prepare distributed applications. One more point here I'm telling to you, all of you observe carefully what I'm telling to you. Java is a distributed programming language because Java has provided a J2EE module to prepare distributed applications. In core Java, maybe we are able to see 20 or 25 number of topics, that each and every topic is a small topic only. Understand it clearly. But of course, the topics size are very less. But depending on the students' awareness, we are discussing the content with somewhat delay, somewhat time. We are taking time to give understanding to the students. But topics wise, they are small. But if you take J to EE, each and every topic is almost equal to one core Java. Servlets is one of the topic equal to core Java. JDBC is one of the topic. Of course, it's a part of the core Java, J2SK, but still I'm telling that JDBC is equal to core Java. EJBs equals to triple time, 4 times core Java. Understand my point? So many concepts are available there. Servlets, JSPs, JSTL, and expression language. Next one is after that. JSTL is okay, fine. EJBs. Next one is the web services. Then after completion of this, middleware services are available. Set of middleware services. Almost 30 to 40 middleware services are available. Luckily, we are not using all the J2 technologies at present in our market. They're outdated. Almost a majority of the J2 technologies are outdated. EJBs is totally gone. Web services is having a little bit. Alternatives are available. Frameworks are available. Spring framework is available. Spring framework is ruling the market. If over the Spring also, Spring Boot is available. Now it is currently trending. Spring Boot with microservices. We are going to understand. Effectively, we are going to understand that content here. No to worry for it. Very good R&D work I had already on Spring Boot and microservices. The perfect content we are going to understand. But the point I'm telling there. So luckily, majority of the topics in J2EE are outdated. Because of that reason, we are at safe side. Still, if the topics are in utilization now, then we are unable to spend the time to learn all these concepts now. That EJBC is one topic is available, it is an outdated, nobody is using nowadays, no. But less number of companies are still using that EJBC topic. That one topic is sufficient to take the Java classes up to 1 year of time. Only one topic. Understand it here. So that's why that because of that reason, here we had that concrete boundaries for our programming languages. No, within that boundaries, we are going to understand the content. Otherwise, we are unable to discuss the total J2E content. Don't expect it. J2E totally we are unable to discuss there. Not possible. Even 10 years of time, if we spend now, the time may not be sufficient. In that way, the J2E module was provided. That means then the implementation of J2E is very good. No other language is having this type of implementation. That is the reason why initially J2 is getting very, very good demand. Later on, some alternatives are coming. Because of that reason, people are not thinking much about it anyway. Okay, sir, leave this point here. Finally, the point is what? What is the point here? We have to remember Java is a distributed programming language. Why? Because to prepare distributed applications, Java has provided J2EE module. Java distributed programming language, J2EE module. Remember it. How Java is a distributed programming language? Because of J2EE module. Because of what there? J2EE module. Yes, sir. All of you are getting clarity on this? Leave this point here. Next one is after that. The next point is like what there? Interpretive programming language. Right. Then what is it? Next one? You know, interpretive programming language. Right. All of you understand this clearly. What is the meaning of this interpretive programming language? What you are understanding about this? Java is not only compilative programming language. Java is not only compilative programming language, but also an interpretive programming language. Not only compilative programming language, but also what their interpretive programming language. In other words, I'm telling that Java is both a compilative and as well as what their interpretive programming language. Yes, fine. How can you say it is a compilative programming language, or how can you say it is an interpretive programming language? What reasons here we are having? Answers are very clear. All of you observe carefully. Java is both compilative programming language, both compilative and an interpretive programming language. I need to give clarity on this. What is the meaning of this compilative programming language and what is the meaning of this interpretive programming language? Point number one. First, let us understand how Java is a compilative programming language. In general, we are going to write programs in a high level language, in our understandable language. Understandable language is what their high level. C is in high level, C++ is in high level, Java is in what their high level. That is our understandable representation. At the end, Who is going to execute our Java program? JVM. At the end, who is going to execute our Java program? JVM. Who is that JVM actually? It's a mission. JVM is what their mission. So definitely mission. Okay, mission. Definitely mission doesn't require the program in high level. What we have written program. JVM require the program in low level. Low level what their mission language, mission code. So but here we are able to write the program in high level. Mission require the program in what their low level. So if we want to execute our program, first we need to translate our program from high level to low level. First we have to translate our program from high level to low level. Exactly. Here to translate the program from high level to low level, there we have to perform compilation. There we have to perform what there? Compilation. Please all of you recognize my point clearly, what I'm telling to know. To perform the program from high level to low level, there we require like what there? Compilation. It's mandatory. Without performing compilation, the program is not going to be converted from high level to low level. Understand my point clearly? What I'm telling you know. Right, sir. That's nice. So point number one. To translate program from high level language to low level language, we need compilation. Point number one. Point number two. Who has written this Java program? Human being. Yeah, myself is human being, yourself is your human being, even James Gosling is also what their human being. When we write the program, definitely some mistakes are going on. Java has given a set of rules and regulations. As per the rules and regulations, we have to write the program. Yes, definitely we start to write program. We are starting to write the program by following Java rules and regulations only. But in some situations, we may have some mistakes. We may have some mistakes. Having mistakes in our program is not a crime. But what is a crime? Without checking whether our program is having mistakes or not, trying to execute the program is a crime. Without checking, executing program is a crime. I forget my point or not? So, but having mistakes is a common thing. Getting mistakes is very common. Everybody will get mistakes in our programs. Directly, I'm telling that. Even if we call James Gosling to come here and to write Java program, definitely may have some mistakes. But before going to execute the program, as per our responsibility, we have to check whether mistakes are available or not in my program. If we have mistakes, we have to get some notifications. There we have to correct it. If no mistakes are available, let it to execute. Got my point or not? But how we are going to check whether our program contains mistakes or not? Who is going to take responsibility of checking our mistakes before going to execute our program? There again we require what? Compilation. There again what we require? No, compilation. I'm giving two responsibilities of the compilation. Now tell me, one is what there? Translating program from high level program to low level program. Second one is what there? Error checking. Second one is what there? Error checking. Please remember this. Now onwards, maybe at any time I'm going to ask this question like what is the purpose of compilation? There we have to give response, two responses now. One is what there? Translating program from high level language to low level language. Second one is what there? Error checking. That's it. Error checking means that checking whether our program contains errors or not. Understand my point clear now? So these are the two requirements of the compilation. So Java is both a compilative and an interpretive programming language. Why? Because we need compilation. That means Java program need compilation. Java applications need or requires, Java applications required compilation, requires compilation to translate the program from high level language to the low level language, machine understandable language. Java applications requires compilation to translate the program from high level representation to high level language to low level language, and to check the developers mistakes, in Java applications, and to check the developers mistakes in Java applications. Because of this reason, what we required, compilation is required. Java applications require compilation to translate the program from high level language to low level language, and to check the developers mistakes in Java applications. Checking developers mistakes in Java program in the sense what they're error checking, translating from high level to low level, and error checking. They are the two responsibilities of the compilation. Now tell me, because of this reason, Java is a compilative programming language or not? Definitely Java is what there? A compilative programming language. That's nice. Next one is Now, all of you observe carefully. Java is an interpretive programming language. That's nice. Now see this one. Now tell me, simple question. Who is executing our Java programs? Come on, who is executing our Java programs? JVM, Java Virtual Machine. JVM is executing our Java program. That's nice. Inside the JVM, who is executing our Java programs? Inside the JVM, who is executing our Java programs? Previously, I given a list. If you open the JVM, 5 components are available mainly. What are the 5 components? Now tell me. Class loader. Next one is a JIT compiler, JIT compiler. Third one is what? Interpreter. Fourth one is what there? Garbage collector. Next one is what there? Security manager. Out of all these 5, third one is what? An interpreter. Third one is what? No? Interpreter. All of you are getting it or not? Interpreter. That interpreter is responsible for executing Java programs. Interpreter is responsible for executing Java programs. Understand my point clearly now? All right, sir. Now, Java applications require an interpreter to execute Java programs. Right, to run Java programs, an interpreter is required inside the JVM. Java applications require an interpreter inside the JVM. Inside the JVM, in order to execute Java programs or Java code. That's it. So because of these two reasons, we can conclude that Java is what there? An interpretive programming language. Nice. All of you are getting clarity on this point now. Leave this point here. Right, sir. Finally, I'm asking there. Interpretive is a title. How Java is a compilative programming language? Now tell me. To translate program high level to low level and to check the developer's mistakes, error checking. Because of these two reasons, what is required? Compilation is required. That's why Java is a compilative programming language. How Java is an interpretive programming language? Why? Because Java applications requires an interpreter to run the Java code inside the JVM. That's why Java is what there? An interpretive programming language. Leave this point. Next, come to the next point here. High performance programming language. All right, sir. How we are going to say this? Java is a high performance programming language. What is the reason for it? No specific reasons, sir. Very, very simple reason. Easily we can understand, but observe carefully. Directly I'm giving the point to you. Now observe carefully. Java is Java is a high performance programming language. High performance programming language. Java is a high performance programming language. Why? Because observe carefully. Why? Because Java is multi-threaded programming language. Java is a multi-threaded programming language. Okay, this is reason number one. Multi-threaded programming language. Java has Java has Java has a separate component in the form of JIT compiler inside the JVM to boost application performance. Or else maybe instead of saying this application performance, to boost JVM performance. Okay, listen carefully. Java is a multi-threaded programming language. You know already the point. Single threaded model, multi-threaded model. Single threaded model is allowing only one thread at a time, but multi-threaded model is allowing more than one thread at a time. One thread in the sense sequential execution, multiple threads in the sense parallel execution. Sequential execution in the sense more execution time. Parallel execution in the sense like what there? Parallel execution in the sense less execution time. More execution time in the sense less performance. Less execution time in the sense what there? More performance. Java is following multi-threaded model. So Java is a multi-threaded programming language. Application execution time is less. Performance of the applications will be more. That's the reason why Java is what there? High performance programming language. And the second reason is like what there? Java has a separate component in the form of JIT compiler inside the JVM to boost JVM performance. If JVM performance is good, automatically application performance will also be good. Automatic Java programming language performance is also be good. Right, what happened? Observe carefully. It may take some time here. If you want to understand it, then I'll give much clarity. Why JVM is improving the performance now. Yeah, try to understand. You'll understand it, no problem. I'll give the information to you now. All of you okay? Okay, can I explain the content? But your complete attention is required. Then only we can understand it now. Before going to understand, before going to talk about that actual topic, I want to take one simple example. First, understand that example. Then we'll go for the actual concept. For example, I have my core Java book. I have some hard copy. My requirement is what? I want to get 100 copies of this core Java hard copy. I want to get 100 copies of this core Java hard copy. So how do I have to do? First of all, I have to take my book. I'll go to Xerox Center. There might be some Xerox Center person is available. Just I asked him, this is my original book, my hard copy. Make nearly 100 copies of the same book, Xerox copies. Then I asked again, then how much time you want to take to get 100 copies now? Hardly 3 hours of time it will take, sir. Just after 3 hours of time, just you can come to me. Just you can collect over 100 copies now. Yeah, nice, good. 3 hours of time. Then I thought of it. In the less time he's going to prepare all 100 copies. No, I thought of it. Very good. Definitely will finish it. Then after that, I gave him some maybe that work took him. Then I left from there. Then I went outside my way. For example, I went for movie. 3 hours of movie was completed. Again, I come back to the same Xerox center. Just I have asked there. Now, if you give that 100 copies there, then I will go outside. Then immediately what he has given reply now. Sorry, sir. I thought of it, it is going to be completed by the time of taking that walk, but unfortunately it was not completed. Asked him, then okay, it's okay, no problem. But how many books you completed as of now? Just I complete only 20 books, sir. Are yeah, 3 hours of time, only 20 books. How is it possible? Then why? Why we are wasting your time? Then what process you are following now? First of all, tell me. Then what is the process is following? They had very good Xerox machine actually. The updated Xerox machine, it was. But what he is doing there, first he are taking the book now, he opened the scanner, then he tried to scan each and every page of that book. Okay, that right. All right. Then what happened there? He got one Xerox copy from that scanner. One book is available. After getting that, again he has taken that original copy. Again he's trying to scan the book. Then he's getting second copy. Third one. Third time also be scanning entire book and getting third copy. Fourth time also scanning entire book and getting fourth copy. Understand my point here? But how many? 100 copies if you want to get 100 times he has to scan the book, 100 times he has to get the Xerox now. Is it necessary to scan 100 times that book? Not necessary. Just one time scanning is sufficient or not? But he has not followed that option. What he has followed there, all 100 times he's trying to scan the book, 100 copies he want to get. That means his mindset is what? His thinking is what there? For every Xerox copy, one time we have to scan the book. That he has the fundamental. So internally thought of it is not the right person there. At least as we know the process there, we have to give that information to him. I call him, Arey yaar, this is not the right process there. Just do one thing, scan one time and go for settings in our Xerox machine. Number of copies 100, type there. Then start that Xerox now. Automatically 100 copies will come there directly. Just we have to wait for the completion of one copy. When one copy is completed, just separate it. Then you can go for what there, your like what there, winding of like what there wires now, right? The spiral winding. Just we can go for it. Like this, we can follow the work, then easily we are able to complete. Like this, I given some information there. The letter might be followed that, able to give that information. Now here the point what we have to understand. To get 100 copies of the same book, 100 times scanning is not required. One time scanning is sufficient, then we are able to get 100 copies. The point is clear or not? If you catch this point now, my next point is very easy. All of you are getting clarity on it. To get 100 copies of Xerox, 100 copies of a book now, 100 times scanning is not required. One time scanning is sufficient. Or if you have any confusion in one time scanning, then go for second time scanning. That's more than sufficient. But don't go for 100 times scanning for getting 100 copies of the book. Clear? Yeah. Now listen carefully. When I compile the program, dot class file I'm getting. Inside the dot class file, I'm having bytecode. What is that bytecode actually? Not directly executable code. Bytecode is an intermediate code. Bytecode is what there? An intermediate code. But if you want to execute this bytecode on any of the operating system, if you want to execute that bytecode in any of the operating system, that bytecode must be converted to operating system conversions, operating system representations. A bytecode with local operating system representations is called a native code. A bytecode with local operating system representations is called what there? Native code. All of you are understanding up to this now? Come on, everybody. Now tell me, first I prepared a Java program. I compiled Java program. What file I'm getting there? Dot class file. Inside the dot class file, what code is available? Bytecode. Bytecode. Everybody, just try to speak out. Bytecode is required. Bytecode is generated. What is the nature of that bytecode? What is the nature of that bytecode? The nature of that bytecode is what? Not directly executable code, it is an intermediate code. But if you want to run this intermediate bytecode in any of the operating system, that bytecode must have the local operating system representations. To have that local operating system representations, first we have to convert that neutral bytecode to local operating system represented bytecode. So local operating system represented bytecode is called what? Native code. So finally we need to convert the program from bytecode to native code. Bytecode to native code conversion is required. Get my point or not? After getting that native code, then execute that native code. After getting native code, then execute that native code. If we execute native code, we are able to get output. All of you are getting clarity on this point now? Process I'm telling there. Java program, compiled it, generating dot class file, contains a bytecode, not directly executable code. After that, what is required? Converting neutral bytecode to local operating system represented bytecode, means that bytecode to native code. After that, execute that native code, then we are able to get output. Tell me, what are the stages now? Java program, compilation, dot class file, bytecode to native code execution, output we are getting. Clear or not? Fine, sir. Compilation could be performed by compilation process. There is a separate process. Blindly you can think of it compiler. Okay, major part is compiler, but four machines are available. Compiler. Okay, fine. When dot class files are generated, who will perform translating program from bytecode to native code and executing that native code? Who is performing that? JVM is performing that. Yes, sir. Who is performing that? JVM is performing that. Remember carefully. Inside the JVM also, interpreter is performing that. Inside the JVM also, what it is performing there? Interpreter is performing translating bytecode to native code and executing that native code. Interpreter is responsible for it. All of you okay or not? Who's responsible for it now? An interpreter is responsible for translating program from bytecode to native code and executing that native code. Interpreter. Okay? Listen carefully. First of all, give confirmation. All of you are getting clarity up to now. Can I move forward? My next point is important. Okay. I have written a Java program. Listen careful. I have written a Java program. I define a add method one time. Definition is one time. Implementation for add method is one time. So for example, for the sake of your clarity, I have written a Java program class, for example, calculator. Understand it now. Don't think much about it. Void add method I define. Just assume it. There 100 instructions here I have written. 100 lines of code here I have written. This is available. Yes, sir. Class calculator void 100 lines of code is available. Class test. Inside this, public static void main. Public static void main string array args. Then inside this, observe carefully. Add method I'm calling 100 times. How many times I'm calling add method, sir? Now tell me. 100 times I'm calling add method. Okay, finally, what is the point we have to understand? I've written a Java program where I define add method one time. This is method definition only one time. But how many times I'm calling this add method? 100 times I'm calling this add method. Okay, right. Now come for our content here. I prepared Java program which contains add method definition one time, but calling add method 100 times. I compile it. Data class file is generated. Okay, if I give the data class file to the JVM, inside the JVM interpreter, what it will do? it has to translate our program from bytecode to native code. Then after that, executing that native code. How it is translating that bytecode to native code? No, observe carefully. When interpreter encounters first time add method, when interpreter encounters this first time add method, now it is translating this add method bytecode to native code first time. Then after that, executing that. When it encounters second time add method call, okay, again what interpreter is doing, converting this method bytecode to native code and executing it. When it encounters third time add method call, again translating that add method bytecode to native code and executing it. 100 times, 100 times call of this add method, all 100 times interpreter is converting that add method bytecode to native code and executing that native code. So got my point or not? How many times that interpreter is performing the translation? 100 times translating that bytecode to native code and executing that native code. Get my point or not? Now tell me. One time translation of add method bytecode to native code to another time translation of add method bytecode to native code. Any difference is available? The conversion, that resultant converted bytecode is same or not? That native code of add method is same or not? No changes are going to be available. The native code is same. But how many times it is performing conversions? No. Conversions it is performing how many times? No. 100 times. For the sake of calling 100 times that method. For executing 100 times that method, 100 times it is translating now. Got it or not? Now here, performing translation of that bytecode to native code 100 times is a problem. Not required, not necessary, unnecessary. One time is sufficient to execute the same converted bytecode, native code 100 times. It is not necessary to translate our program from bytecode to native code 100 times. One time is sufficient. One time is sufficient. Then remaining times directly we can execute the translated code. One time if we translate bytecode to native code, keep that native code available and execute the same bytecode, same native code wherever we require. Execute the same native code number of times whenever we require now. Then if you follow this approach, performance will be improved. I'll forget my point on it. But what is the default nature of the interpreter? The default nature of the interpreter is interpreter by default. It convert the program from bytecode to native code and execute it. If you call a method 100 times, no, 100 times it's trying to translate the program from bytecode to native code, 100 times it's trying to execute the program. Where 100 times is not necessary. Exactly. In this particular point, JIT compiler was provided by Sun Microsystems. What compiler? JIT compiler. JIT compiler has provided. Then what the JIT compiler is saying? No, JIT compiler will monitor JVM execution, JVM translation process. When JVM is translating, that means when interpreter is translating a method bytecode from bytecode to native code one time, two time, three time, JIT compiler will monitor it and JIT compiler will take count value. JIT compiler will maintain that count value of that particular method calls. How many times that interpreter is translating, now it is counting. It will wait up to the threshold value. It will wait up to the max limit. Maybe what is the max limit? No, maybe 5 or 10 or we don't know. Depends on the JVM implementation. It will wait until the threshold value. Once that count is reached to the threshold value, once the count is reached to the threshold value, JIT compiler check it. One time okay, second time okay, third time okay, fourth time okay. Then it decided no. Unnecessarily this interpreter is doing some work. No, unnecessarily it is reducing the performance of the JVM. No, immediately JIT compiler will come into the picture. Now JIT compiler will ask to the interpreter, just wait here. Your work is sufficient, just wait here. Every time don't translate like this. JVM performance is going to be down. Just wait here. What I will do, no, I will convert it permanently. I will convert that bytecode to native code permanently. Wherever you require this particular native code, just call to me. Ask me. Definitely I will supply that native code to you permanently without translating every time. Without translating every time, I will provide that permanently that native code to you. We can execute it wherever we require that. Like the JIT compiler will come into the picture. JIT compiler will convert one time, final time, from that method bytecode to native code, and it will supply that native code to the interpreter. When interpreter requires one more time that add method call, just it will get native code from JIT compiler and execute that native code and perform the required operation. Again if interpreter requires the same operation there, again it will get the native code from what there, JIT compiler, and JIT compiler will supply that native code. JIT compiler will that means interpreter will execute that. Interpreter will take that bytecode, native code, and interpreter will execute that native code. Then finally it is able to perform the operation. Now here what happened there? 100 times call of this add method. Because of the JIT compiler, interpreter is not performing 100 times translations. Just maybe up to threshold value, it is performing translations. In all the remaining times, directly it is going to execute the permanently generated native code. Now tell me here, JIT compiler is boost the performance of the JVM or not? Think a minute about it. If JIT compiler is not available, what interpreter is doing the work? Every time it is translating that bytecode to native code unnecessarily or not, where automatically execution time will be increased or not. When execution time is increased, performance of the application will be reduced or not. Observe carefully. Now to say Java is a high performance programming language, directly or indirectly JIT compiler is providing some help. JIT compiler is a main component to improve the performance of the Java programming language. Because of this kind of components only, Java is what there, a high performance programming language. Good sir, at least might be then almost 70 to 70% of the people are understanding this topic today. Feel very happy. Actually, in my previous batches, when I have a doubt on it whether you are going to understand it or not. That's why in general I am not going to talk about this much of content in my previous batches. But now you understood it. I feel very happy for it. Maintain the same tempo. Easily we can understand. Java is not a big deal. Java is after all. Don't look the Java in a big hole. A small, I said to you already, is one of your subject throughout your career. Out of 90 number of subjects, one of the subject is Java. Nothing is there inside the Java. If you understand today's point, whatever the point, just last 10 minutes of time I explained to you, nothing is there Java. You can understand anything inside the Java. Even if I start today advanced Java, easily we can understand. But the point is what? Your complete attention is important. Your complete attention is important. Now you proved it. Now you are understanding the content properly because of your complete attention only. Okay, right sir. Now let's move on to the point here. One more point here I'm telling to you, right sir. Now observe carefully. Now finally I'm asking one question to you. Now tell me how Java is high performance programming language because of two reasons. What is the first reason? No, Java is multi-threaded programming language. Second one is what there? Java has a separate component in the form of what? JIT compiler inside the JVM to boost JVM performance. Next one is, all of you observe carefully. Java has a very good, rich set of features. Java has a very good, rich set of features like distributed, portable, robust, object-oriented, and so on and so on and so on and so on, to make Java as a high-performance programming language. High-performance programming language. Yeah, we have to give credit for its rich set of features also. A simple programming language, object-oriented programming language, platform independent, architecture neutral. Then what next one? Get portable, robust, like what there, and so on and so on. So many. Because of this rich set of features, again, we can conclude that Java is what there, high-performance programming language. That's it. This is the total information about what there, Java features. All of you okay? No? All of you okay? Shall we go for a small quiz? Just I'm going to give only feature name, but we have to give that pinpoints about that feature. I think some people are not ready for it. Having question mark faces now. At least 2 to 3 features I will ask there. If you are good, I'll go to the next topic. Otherwise, then I have to give 2 minutes of time. I have to refresh it. And now tell me how Java is simple. Come on, less execution time, less memory utilization, no confusion oriented features, simple syntaxes. That's nice. How platform independent? Compilation is on one machine, one operating system, execution is on another operating system. How portable? Come on, right? Your point is right. It is able to run its applications under all the operating systems, under all the hardware systems. It's a portable. Okay, fine. How is it robust? Good memory management system in the form of heap memory management system. It's a dynamic memory management system. It allocates and deallocates memory for the objects at runtime. Then having very good exceptionality mechanisms in the form of very good predefined library to represent and handle almost all the exceptions. Right, sir? How an interpretive? There we have to give the information. Java is both comparative and interpretive programming language. How Java is comparative programming language? Compilation is required to translate the program from high level to low level and error checking. How it is an interpretive? To execute Java program, we require an interpreter inside the JVM. That's nice. Right, sir. Then how Java is distributed programming language? Because of J2EE module to prepare distributed applications. Because of what there? J2EE module to distribute. That means to prepare distributed applications. Okay, sir. Good. At least not satisfied, but okay. But one time if you study, you'll understand it clearly. No? Right, sir? Please try to remember this topic. I'm going to complete. I completed it no. But in the next attempt, how you are going to be available. If you close this material, if you check on the air, what is Java feature, all points we have to get in our mind. Then only you are perfect Java developer. You must have subject in our mind. Then we have to implement program easily in our systems. If you're not having subject in our mind, not possible to prepare the programs easily in our systems. Right. Leave this point here. The next one is coming to the next one here. Java naming conventions. Java naming conventions is the next topic. Everybody has to understand these naming conventions. Java naming conventions. First of all, I'm telling to you clearly, Java is a case sensitive programming language. What's that? Java is a case sensitive programming language. Java is a case sensitive programming language. Nice. But what is the meaning of this case sensitive programming language? Listen carefully. Wherein Java applications, there is a separate recognition for lowercase letters and for uppercase letters. There is a separate recognition for lowercase letters and uppercase letters in Java applications. Where in Java applications, there is a separate recognition for lowercase letters and uppercase letters. That means what I'm trying to say, capital ABC is not equals to small abc. Both are different. In other programming languages, both may be same. Say for example, SQL is available. Structured query language, SQL queries we are writing there. In SQL queries now, select star from EMP1. At the same time, if you write select star from EMP1, both are same. No difference is available in SQL. Why? Because SQL is not a case sensitive programming language. It's a case insensitive programming language. Understand? But Java is what? Java is a case sensitive programming language, where in Java applications there is a separate recognition for lowercase letter and for uppercase letters. But here the question is, to use lowercase letters and uppercase letters, Java has provided the following conventions. Where to use lowercase letters and where to use uppercase letters, to specify that Java has given a set of conventions. What exactly the set of conventions here? All of you understand it clearly. But before going to start these conventions, you have to believe one fundamental point in Java. You have to believe one fundamental point. We have to trust on this fundamental point. What is that point here I'm telling to you? Listen, all of you know. In Java applications, complete programming is going to be happen. Programming is going on the elements, on the topmost elements, classes, abstract classes, interfaces, enums, variables, methods, constructors, packages, and so on. These are the main programming elements. Come again, what are the various programming elements? No, classes, abstract classes, interfaces. What are these three? Classes, abstract classes, interfaces, enums. These are top level container related components. After that, inside these classes, abstract class, interface, and enums, we are going to declare variables, methods, constructors, and so on. Outside of the classes, we are going to declare packages, import statements. What are my packages? They are mainly programming elements. Only these names only we are going to use. Java programming is associated with these names only. That we can check even that microservices. No, we can check that microservices. The last topic of the Java, we can check there. There also we are going to use variables, methods, classes, constructors like blocks and packages. Only these concepts only. Java is not any other one. Only these concepts. Understand my point here? Now the conventions are available on these programming elements only. The conventions are available on these programming elements only. Now let's understand the point here. Point number one. Put more concentration. All of you know. I'm going to write the point here. All Java classes names comma abstract classes names comma okay interfaces names and enum names must be started with an uppercase letter. Must be started with the uppercase letters. With the uppercase letters, and the subsequent symbols must also be uppercase letters. I'll give examples here. By that you are able to get much clarity. First of all, read out the statement what I've given there. Classes, abstract classes, interfaces, enums. They are the high-end four topmost elements in Java. Must be started with an uppercase letter, and the subsequent symbols must also be uppercase letters. And the subsequent symbols must also be uppercase letters. What is the meaning of the subsequent letter? Understand it now. Simple. First word must be started with an uppercase letter. Second word onwards, every word must be started with uppercase letter only. That means every word must be started with uppercase letter. Every word must be started with what there? Uppercase letter. That is a convention. Every word started with an uppercase letter. Examples I'm telling to you. Observe carefully. String is a class name actually. Is a single word which is started with what there? S capital. Next one is after this string buffer is also be a class in Java. String buffer, two words are available. Then string must be started with uppercase S and buffer must be started with uppercase B. Right, sir. Next one is what there? Input stream reader. Input stream reader. Three parts are available. In input, I is uppercase letter. In a stream, S is uppercase letter. And in reader, R is what there? Uppercase letter. I'll forget my point or not. Like this, we can take any class now. Every class must be started with an uppercase letter, and the subsequent symbols also must be started with what there? Uppercase letter. Now coming to the point number two. All of you are getting clarity on first point. Now tell me, what is the convention about the classes, abstract class, and interface and enums? Simple. Every word must be started with an uppercase letter. Every word must be started with what there? An uppercase letter. Try to remember it. All right, sir. Next one is. And previously, I got a funny question from one of my previous students. No? When I given this example, input stream reader, what are you saying that, sir, input, two words are available. How we are saying that to single word? I should be, P should be captured here. Why you are not writing that P is captured? Now it is violating Java rule. No, input is a single word in Java. Don't make it is input. Even in English also, input is a single word. Input is a single word. Don't separate both of them. In is different, put is different, input is different. Three words. In English also no. So don't have such kind of questions here. Right? Input is a single in Java where I is a capture. Started with I. Okay, fine. Leave this one. Next one is all Java variables names. All Java variables names. You know already variables here. Int I is equal to 10, int B is equal to 20, or maybe int envo is equal to 1, something else. Variables here we have taken. In Java, all variables names must be started with a lowercase letter, but the subsequent symbols must be uppercase letters. That means, what is the meaning of it now? All Java variables must be started with all Java variable names must be started with a lowercase letter, but the subsequent symbols must be what there? Uppercase letters. What is the meaning of it actually? First word, first symbol, first word started symbol. First word is started with a lowercase letter. Second word onwards, every startup symbol is what there? Uppercase letter. Only first word, first symbol is what there? Lowercase. Second word onwards, every word must be started with what there? An uppercase letter. Examples here I'm telling to you, observe carefully. In, in, single word, I is small. Out is a single word, O is a small. ERR is what there? Single word, E small. All these are predefined variables in Java. Next one is page context is available. What is it? No, page context is available. In a page context, P is small and C is capital. P is small and C is capital. Next one is what there? Body content. In a body content, B is small and C is what there? Capital, uppercase letter. Right, sir? Like this. Next one is one more example. Temp, EMP, temporary employee address. Three words are available. First word startup symbol is what there? Lowercase. Second word onwards, every startup symbol is what there? Uppercase letter. Understand my point clearly? Temp, EMP, Understand my point clearly? Permanent STD address. Right, sir. Understand my point here? Permanent student address. P is small, S is capital, and A is capital, and so on. This is about like what there? Rule number 2. That what we are getting. All right. Now, all of you understand it now? Whatever the rule we have seen for variables, whatever the rule here we have seen for variables, the same rule is available for what their methods. The same rule is available for what their methods. Now the point is what? All Java method names must be started with a lowercase letter, and the subsequent symbols must be uppercase letters. Same variables and methods both are having the same role. No separation for it. Both are having what their same role. Variables and methods both are having same convention. Everybody understand it clearly. Now what is this convention actually? All of you understand it clearly. Concat is a method. In concat method name, C is small. Why? Because only one word is available. Next one is what there after this. For name is a method in Java. Two words are available. For name, F is small and N is capital. Get input stream method. Three words are available. Three words are available. What are the three words? No, get input stream, where G is small and I is what there? Uppercase letter, and S is what there? Uppercase letter. Get input stream. Next one is get input stream reader. Get input stream reader. Now again here, what is available here? Get G is small. In input, I is capital. In a stream, S is capital. Reader is what there? R is capital. Like this, here we are able to prepare what there? All the Java method names. So variables and methods both are having same role. Now tell me here, all of you now tell me, what is the convention for classes? Every word must be started with what there? Uppercase letter. What is the rule for variables and methods? First word is started with the lowercase letter, and the second word onwards, every word is started with the uppercase letter. Remember this. Next one is point number 4. Observe carefully. All Java constant variables must be provided in uppercase letters. All Java constant variables must be provided in uppercase letters. Right, sir. All Java constant variables must be provided in uppercase letters. Examples, observe carefully. Min priority. Some variable is available in Java, predefined variable, min priority. Norm priority. Okay. Max priority. Min priority, norm priority, max priority. They are the constant variables. In a thread class, they are available, of course. In the threaded class, they're available. They're the constant variables. So by default, we can understand constant variables are public, static, final. By default, constant variables are what they're public, static, final. Understand it now. So they're the constant variables. All the constant variables must be provided in what? No, uppercase letters. All the constant variables must be provided in uppercase letters. Min priority, norm priority, and max priority. Right, sir. This is completed. After completion of this, the next one. All Java package names must be provided in lowercase letters. All Java package names must be provided in what? Their lowercase letters. Right, sir. Now, what are the examples here we have to understand? Java.io, Java.util, Java.util. Next one is Java.sql, or else maybe Java.io, Java.awt.event, Java X dot, Java X dot, servlet dot, JSP dot, tag ext. Like this, number of packages are available. Okay. Java X dot, servlet dot, JSP dot, tag ext. Like this, number of packages are available. But every package name must be provided in what letters? No, lowercase letters. Sir, got or not? Now come again. What exactly the rules and regulations are available? All classes. How we are going to represent that classes names? No. Every word must be started with what? Uppercase letter. Variables and methods names. First word is started with what there? Lowercase letter. But the subsequent symbols, that means second word onwards, every word must be started with what there? Uppercase letters. What about the constant variables? All constant variables must be provided in what? Uppercase letters. All package names must be provided in what? Right, sir. Now lowercase letters. These are hyphen symbols are depending on our requirement, depending on our readability, we can keep. But predefined that variable is available like that I have written. Predefined that variables are available like that, here we written here. Understand it clearly. All right, sir. Good. After this, after completion of this, yeah, not only this convention, this convention is not only in the case of these constants, no. These underscore symbols we can apply in any of the variables, normal variables also. Not only in the case of these constants, no. Inside the normal variables also you can apply what their underscore symbols. There are some points about it. I'll discuss about the points in the future. All right, but all package names must be provided in what their lowercase letters. But remember one small note. One very small note here I'm telling to you. Now observe carefully. Everybody. All these conventions are mandatory while writing predefined library. These conventions must be followed while writing predefined library. Why? Because the complete predefined library was provided on the basis of these conventions only. The complete predefined library was provided on the basis of these conventions only. The predefined library was prepared totally on the basis of these conventions only. So because of that reason, while writing these predefined library, we must follow the same naming conventions. Okay, these are optional for user defined library. These are optional for user defined library. When I'm going to write my own library, when I'm going to declare my own class, my own variable, my own method, these things may not be followed, not mandatory to follow. But even for user defined library also, these conventions are suggestible. Even for user defined library also, these conventions are suggestible. I gave in that actual concept here, but blindly what I am telling now, follow these conventions for both the predefined library and as well as what their user defined library. That will be the good programming practice. If you follow these conventions for both predefined library and user defined library, that will be good programming practice. If you violate these rules and regulations for predefined library, you will get errors. But if you violate these rules and regulations for user defined library, you will not get errors, but not suggestible. Not suggestible. Understand my point clearly? So the point is what there? All the above conventions are mandatory for the predefined library. For the predefined library. All the above conventions are mandatory for predefined libraries. Okay, they're optional for the user defined libraries, but suggestible for user defined library. Right, sir? In a simple words, I've given there. These are about like what there, the naming conventions, what we are having inside the Java. Completed, sir. Next, when we completed this part here, next one is Java programming format. Java programming format. Sorry. Java programming format. This is the next topic. So do one thing, then I will start this completely different topic, next topic, and tomorrow with a fresh mode. We are going to understand this total content here. This is another last topic in introduction part. Last topic in what there introduction. Once it is completed, then I'll start with what there directly steps to prepare first application. Then there I will show like what there how to install Java software, what are the rules and regulations we have to follow. That every content here we are going to understand. Okay, the topic is completed. That's sufficient for it today. But one more point I'm telling there, if I complete the Java programming format, everybody must appear for an exam, written test. I'm going to conduct on this first unit, total on first unit. You have to check yourself, right? Multiple choice questions I'm going to provide. Almost 30 questions you are going to have there. Out of this 30, how many marks you are going to get? Total theoretical points only, no programmatic point. No, why? Because introduction part only. On the base of that introduction, how much you understood there, you have to appear for it. Okay, sir. That's all for today. We'll meet on tomorrow. Thank you. Thanks a lot. Right, sir. Then when it is no, then after completion of the Java program, if you want, I'll conduct it. But again, in the sense, I will give the schedule. Just the day when I'm going to complete this topic. In the next day, you're going to have exam. Okay. No, definitely. Course duration for course. A course will take minimum three more than three. Yes. Yeah, please. Okay, okay. రికార్డెడ్ వీడియోస్ వస్తాయండి మీకు పర్లేదు నేను మళ్ళీ సపరేట్గా బ్యాకప్ తీసుకుంటాను పర్లేదు డెమో ఏం లేదు జరుగుతుంది యాక్చువల్ కాన్సెప్ట్ జరుగుతూ ఉన్నాయి మీరు రెగ్యులర్గా రావచ్చు ఏమైనా ఇంట్రడక్షన్ కాన్సెప్ట్ కాబట్టి మీకు ఏవైతే క్లాస్ మిస్ అయిన ఇప్పటి వరకు మళ్ళీ నేను తీసుకుంటావి సపరేట్ మీన్ వైల్ మీకు రికార్డెడ్ వీడియోస్ కూడా ఇస్తారు మీకు దానికి ఇబ్బంది ఏం లేదు వీడియోస్ వస్తే ప్లస్ నేను మళ్ళీ సపరేట్ తీసుకుంటా క్లాసెస్ ఓకే క్లాస్లో చెప్తాను నేను ప్రతి పాయింట్ ప్రతి ప్రోగ్రామ్ ఎక్స్ప్లెయిన్ చేస్తాను క్లియర్గా అది మీరు ల్యాప్టాప్ తెచ్చుకోవడమే అదే మీరు ప్రాక్టీస్ చేసుకోవచ్చు ఇంటి దగ్గర ప్రాక్టీస్ చేసుకో మీకు డౌట్ వస్తే నా దగ్గర రావచ్చు డైరెక్ట్గా క్లాస్ అయిపోయి ఇట్లా మీరు వచ్చి మాట్లాడవచ్చు చెప్తాను నేను మీకు ఇబ్బంది ఏమంటుంది 1 minute 2 minutes అయిపోతుంది డౌట్స్ ఎంతమందికి ప్రొవైడ్ చేయాలి మనం ఎక్కువ మంది ఉంటారు కదా ఫ్యూ క్లాసెస్ నేను చెప్తాను మీకు అవి బ్యాకప్ తీసుకుంటాను అట్ ద సేమ్ టైం మీకు వీడియోస్ కూడా వస్తాయి వాటి గురించి ఇబ్బంది ఏం లేదు థ్యాంక్ యూ for framework and Ravi, and it may take some time, not immediately. Advanced Java I started at evening time. Advanced Java with the frameworks by separate batch. At evening 7:30 I started there. And frameworks classes again it may take some time. I think within a month of time I will start it. Yeah, yeah. Data structures and algorithm is also required definitely, but not the part of this course, no. But separately you have to understand it. But if you know data structures and algorithm, then that will be good thing. Your resume will get more weightage. This is core Java and advanced Java. Like we can go for it. What there 4 to 5 months of time it will take. Yeah. Okay. Yeah, Subhash, 4 to 5 months of time it will take. But parallel, I'm going to start advanced Java after completion of few topics in core Java. Okay. Yeah, that's all, guys. Then I'll meet on tomorrow. Tomorrow we'll continue the Java programming format content. Right. Thank you. Advanced Java, not immediate. For other batches, I started Advanced Java at evening time, evening 7:30. But for our batch, Advanced Java, it may take some time. Why? Because first of all, at least we have to understand the basics of the core Java. Without having basics on core Java, not possible to understand it. Okay. Yeah, thank you. Right, guys. Now that's all for today. We'll meet on tomorrow. Tomorrow is the remaining content. Thank you.